Ladies and gentlemen, welcome to this enchanting musical journey. Tonight, we invite you to step into a world where the performers are not just musicians, but music robots from the future. With unparalleled technical precision and artistic sensitivity, these robots will present an exquisite performance, blending perfect rhythms with a captivating visual display. So please, relax, open your hearts, and let the melodies guide you through an unforgettable experience. Now, let us warmly welcome our stars of the evening, the music robots.
Introducing the programmable lens system, designed to assist conductors in leading musical ensembles. This innovative technology detects the motion and position of a color block at the tip of the conductor's baton. Installed on the music stand, it focuses on this color block, cleverly ignoring smaller blocks in the background to avoid interference. Key features include precise coordinate detection of the baton's tip, and scale control by dividing the camera's view into 7 equal parts along the y-axis. Each section corresponds to a musical tone, allowing intuitive control of notes. Additionally, the screen is divided into 3 vertical sections to adjust the rhythm based on the speed of the baton's movement. In our setup, we have 3 musicians performing in an ensemble. Traditional Bluetooth connections operate on a one-to-one basis, which requires disconnecting and reconnecting, making the connection time unpredictable. To address this, we have chosen Bluetooth's one-to-many broadcast feature. This allows each device to receive messages simultaneously without any time lag. On our transmitter, we will first compile a set of codes. Only devices with the correct codes will be able to receive messages from the transmitter. Since it is a one-to-many broadcast, all 3 musicians will receive the message at the same time. We assign different codes to each musician, ensuring that only when a musician receives a message matching their specific code, they will take the corresponding action. Next, I will show you how to control the playing notes. Our robot uses a Tomosone car as the base, surrounded by aluminum frames forming a square. Aluminum columns at each corner create a rectangular body. The front, back, sides, and top of the car are fitted with corrugated boards, one white and the others black, to project musical instrument images. 3 cars project a piano, cello, and trumpet, respectively, and light up according to the conductor's instructions. A relay is an electromagnetic switch that controls high-power devices with a low-current signal. When the coil is energized, it changes the contact state to control the circuits on and off. Relays are widely used in automatic control systems. We use the ESP32 chip to control our robot. The ESP32 is a low-power single-chip microcontroller that integrates Wi-Fi and Bluetooth functionalities. This is the MP3 player module. It can read MP3 files from a memory card and play them through a speaker. This light board is very bright. We can see the instrument graphics behind the corrugated board. This is the configuration of our car's bottom. We use a 12-volt lithium battery as the power source. The car is equipped with 4 DC motors and mechanism wheels to provide propulsion.
Thank you all for watching and supporting us. Today's performance has come to an end. We hope you all enjoyed witnessing the perfect fusion of technology and music. Let's give another round of applause for our amazing music robot.